This video provides an overview of the Aparian PMIO scanner providing ControlLogix integration with Honeywell's TDC 3000 DCS-IO. In this presentation, we will provide a brief introduction of the product, describe the configuration and available diagnostics, and discuss a typical migration strategy. The PMIO scanner allows a ControlLogix system to configure and control TDC 3000 IO processors. This provides a reduced risk migration strategy for these legacy Honeywell systems. Instead of replacing all the I/O, which can be risky, a new ControlLogix system can be phased in with little disruption to production. Up to 28 I/O processors can be configured per PMIO scanner. The PMIO scanner provides both I/O link media redundancy and scanner redundancy. The latter requires two PMIO scanners which operate in an active standby configuration. In the event of failure, the standby scanner will take over seamlessly without affecting the IOP operation. A dedicated add-on profile provides integration into Logix, allowing the scanner to be added in the Studio 5000 I/O tree. A wealth of diagnostics are available in both the Aparian slate configuration tool as well as within Logix. This table shows the IOPs that are currently supported. Both the low-level analog and the low-level mux IOPs will be added shortly, and other unsupported IOPs can be added on request. We will now take a look at the scanner configuration. As with all Aparian modules, the PMIO scanner is configured using the Aparian slate configuration software, which can be downloaded free of charge from the Aparian website. There are three methods of IOP configuration using the PMIO scanner. Firstly, manual configuration, where the IOP is added manually and its channels configured as required. Secondly, the configuration can be automatically built by importing exception build or EB files created from a Honeywell system. The third option is the learn function, which scans the I/O link network for IOPs and uploads the configuration from each. Before looking at these configuration options in more detail, let's briefly describe the PMIO scanner operating modes. Run mode is where the PMIO scanner configures and controls the IOPs and is engaged after the Honeywell process managers have been removed from the system. In shadow mode, the PMIO scanner adopts a listen-only approach and can be used to provide input and output readback data to the ControlLogix without affecting the existing process managers controlling the application. The learn mode, as the name indicates, is used only during the learn configuration phase. When adopting manual configuration, each required IOP is selected and added to the PMIO scanner. The IOP's addressing, including module, file, and card addresses, are configured. Depending on the type of I/O, additional per point or per channel configuration can be applied, including input type and scaling to engineering units. When adopting the EB file import approach, multiple EB files previously exported from the Honeywell system can be imported into the slate configuration software. An EB file summary is created, and the user need only to select which IOPs should be imported. All the IOP's general configuration and per point or channel configuration is automatically included. Using the learn configuration method requires the IOPs to be pre-configured by the Honeywell system. The process managers are then removed from the system and the PMIO scanner's learn function invoked. The I/O link network is scanned for IOPs. Each IOP is identified and its specific configuration uploaded. The learn or scan results can be saved to an intermediate file for later offline configuration. A summary of IOPs is provided, and similar to the EB import function, the user can then select which IOPs to import. We will now look at some topology examples. In this first example, we have four 7-slot racks containing a total of 26 IOPs. This can be covered by a single PMIO scanner. Note that the dual I/O link remains intact, maintaining media redundancy. In the second example, we have two 15-slot racks and one 7-slot rack, hosting a total of 35 IOPs. Since the IOP limit per scanner is 28, we will require two PMIO scanners. In the initial shadow mode phase, both PMIO scanners are connected on the common I/O link network, even though their configuration shares the number of IOPs. Before the PMIO scanner is placed in run mode, the I/O link should be segmented so that each PMIO scanner is on its own I/O link segment. The last example shows all three levels of redundancy. In addition to the I/O link media redundancy, two PMIO scanners are added in a redundant active standby configuration. The switchover between the active and standby is triggered by the supplied Logix add-on instruction should one of the scanners or a chassis become disconnected. This topology also includes a redundant ControlLogix configuration. Diagnostics. A number of diagnostics parameters available in both Logix and the slate configuration software. These include status and communication statistics for the scanner as well as for each individual IOP. The slate environment also provides enumeration of the IOP soft faults, further simplifying fault finding. These include field termination assembly or FTA faults and calibration errors. And finally, we look at a typical migration example. We start off with a simplified TDC 3000 system with multiple IOPs located across 2 files or racks controlled by a process manager. The next step is to add the Rockwell automation infrastructure, including Logix, Studio 5000, and FactoryTalk View and Historian. So far, the TDC 3000 system is unaffected. We then add a PMIO scanner, configured for the IOPs, and place it in shadow mode. The PMIO scanner is then connected to the existing IO-Link network. It provides input and output readback data to the ControlLogix and FTView, which can be useful for testing the new HMI, providing historization, and testing the new Logix control code. At this point, the Honeywell process managers are still controlling the application. When the ControlLogix application is ready, the existing process managers can be removed and the PMIO scanner placed into run mode. The ControlLogix is now controlling the application. The final phase would be to decommission and remove the ancillary Honeywell equipment. It is important to note that if any issues are experienced during the changeover, that the system can be switched back in a matter of minutes. This limits production downtime and further reduces the overall risk of the migration. This concludes the product overview of the Aparian PMIO scanner module. For more information, please visit aparian.com or email sales@aparian.com.